Okay, for what we have regarding invertible matrices, okay, first of all, we have a square matrix A, whereupon it is invertible. Okay, first of all, A happens to be a square matrix, in other words, where the number of rows will be the same as the number of columns and vice versa. And also included with the fact that A is a square matrix, okay, we're going to have it such that A times its inverse is going to be equal to the identity matrix, which is also going to be a square matrix, and also you have with the inverse of A times A itself, that is equal to also an identity. And okay, now let's say that if we have it such, okay, we have a square matrix. Okay, and first of all, before I get to the first example, all invertible matrices are square, again, like 2 by 2, 3 by 3 matrices, but the reverse case is not necessarily a guarantee. Not all square matrices are invertible. And now for a case of a matrix that we can determine the inverse of, okay, we have a 2 by 2 matrix A, where we have for the top row we have 1 and 2, bottom row we have 3 and 4. And looking at determining the inverse, so I'm just going to set things up here where we have A, again, consisting of 1, 2, 3, 4, and we'll say that going row by row with the inverse, we'll have designated the variables A and B followed by C and D. And since we have a 2 by 2 matrix for A, the identity that corresponds will be 1, 0, 0, 1. And again, we have a square matrix, and first of all, A times its inverse is equal to the identity. So just substituting, in case you got 1, 2, 3, 4, multiplied by A, B, C, D is equal to 1, 0, 0, 1. And just going back to what we have had in looking at multiplying matrices, okay, so got 1, 2, 3, 4 times AC, and looking at what we have multiplying and combining together. We have for the first combination, for A times its inverse, we have A plus 2C, as well as 3A plus 4 times C. And for the second combination, we have A times the second column of the inverse. Okay, so we want to have, again, B times 1 and 3 plus D times 2 and 4. And combining, okay, we had the top row with B plus 2D, and the bottom row with 3B plus 4D. Okay, so looking at consolidating, okay, so you have 1, 2, 3, 4, A, B, C, D. Again, just going back to what we had in the setup. And again, you're going to have the product equal to the identity. And just looking at what we have taken, going column by column and clustering the portions. Okay, so you have A plus 2C, B plus 2D at the top. At the bottom we have, for the first column, we have 3A plus 4C, followed by what we have in the next column, which we have at 3B plus 4D. And again, we have equal to the identity where we have 1, 0, 0, and 1. Okay, so looking at A plus 2C is equal to 1 and 3A plus 4C is equal to 0. If I take the augmented matrix, okay, from which I have to originate from this system, so I have 1, 2, 1, 3, 4, 0. For following through, okay, to get to the reduced row echelon form, so with the second row converting the 3 to 0, I'm going to take R of 2 minus 3 times the first row elements. So I'm going to have 0, negative 2, and negative 3. And to get closer to the reduced row echelon form, this negative 2 in the bottom row will be converted to 1. So I can take negative 1/2 of the second row. So I'm going to have 0, 1, and 3 halves. And then for what I have at the top row, I got 1, 2, 1. So I had the 1 that I want in the upper left-hand corner. The 2 that I have in the middle, I want converted to 0. So I'm going to follow through and take the top row and deduct twice the second row elements. And so we're going to end up with the transformation from 1, 2, 1 to like 1 minus 2 times 0, which is 1. 2 minus 2 times 1 is 0. And 1 minus 2 times 3 is going to be 1 minus 3, which is going to be negative 2. So I already have it where A is equal to negative 2 and C is equal to 3 halves. Now for the other setup that I have, okay, so I have B plus 2D is equal to 0, 3B plus 4D is equal to 1. So for the augmented matrix, I got 1, 2, 0, 3, 4, 1, and putting in terms of the reduced row echelon form. I'm going to have the exact same operations, but different constant values to the right. So I have R2 minus 3R1, followed by negative 1/2 of R2, and R1 minus 2R2. So for the first two column values, I'm going to have that bit of history to repeat. But for the values on the right, whereas before I started out with 1, 0, this time I'm starting out with 0 at the top, 1 on the bottom. And for the follow through here, it's going to turn out that B is going to be equal to 1 and D is going to be equal to negative 1/2. So again, we had that A was equal to negative 2, C was at 3/2, B was at 1, and D is equal to negative 1/2. So consolidating, okay, our inverse matrix of A is going to be negative 2 and 1 in the top row, and the bottom row we have 3/2 and minus 1/2. And there's another way of going about solving for the inverse, okay, and along with the rules, okay, whereupon if I had the A as an invertible matrix, first of all, A is a square matrix, and in addition to where the product of the matrix and its inverse is equal to its identity, and also where the inverse times A is equal to the identity matrix itself, I'm also going to have this property of where A times the identity is equal to the identity times the inverse of A. So going back to the square matrix I started out with, okay, so designating what I have for A times I. So A I have at 1, 2, 3, 4, and clustering with the identity. So I'm going to have what looks like a bit of a 2x4 matrix that is established, but just clustering together. So I have 1, 2, 3, 4. I have 1, 0, 0, 1, and putting what I have in terms of reduced row echelon form. So I'm going to have R2 minus 3R1, kind of like what I did earlier. So I'm going to have 1, 2, 1, 0, and I have 0, negative 2, negative 3, 1. And again, the negative 2 I want converted to 1. So I'm going to take negative 1/2 of the second row. So these numbers here would change over to 0, 1, 3/2, and negative 1/2. And for the first two columns, okay, I want 1, 0, and the 2 I have here, I want converted to 0. So I have like a 1, 0, 0, 1, kind of have the left-hand side in terms of the identity. And so for what I have, taking the second row elements, multiplying by 2, or taking away twice the second row elements from the first row, I'm going to have first row is going to be transformed to 1, 0, negative 2, 1, and I have 0, 1, 3/2, and negative 1/2. Notice for the last two columns, the values I'm going to have in reference to what is going to be the inverse. Okay, so just again, so I have A times I is equal to I times the inverse. And guess what? We're going to have that bit of history to repeat. So I had before negative 2, 1, 3/2, and negative 1/2. And I had that bit of history to repeat. Now, let me give you just another case. And let's say that if I had that A is equal to negative 1, 2, 4, and negative 7 as I read row by row. So I have A times its inverse is equal to the identity, and just kind of carrying what we have here, just separating the A and C apart from the B and D elements. So again, I have A times negative 1, 4 plus C times 2, negative 7 is equal to 1, 0. Simultaneously, I have B times, again, negative 1 and 4 plus D times 2 and negative 7 is equal to 0 and 1. And just for what we have, if we itemize, okay, so clustering, so I have negative 8 plus 2C at the top, 4A minus 7C at the bottom. And again, I have is equal to the left half of the identity, which I have at 1 and 0. And for what I have displaying as an augmented matrix, so I'm going to have negative 1, 2, and 1 for negative 7 and 0. And if I look at transforming the negative 1 to a positive, I'm going to take the opposite sign of the first row. So negative 1, 2, 1 is going to be transformed to 1, negative 2, and negative 1. And okay, so and just transforming the 4 to a 0. So I'm going to take the second row minus 4 times the first row elements. So 4, negative 7, 0 is going to be changed over to 0, 1, and 4. Then finally getting to reduced row echelon form. If I add twice the second row elements to the first row, I'm going to have 1, 0, 7, while I had the bottom row consisting of 0, 1, and 4. So we're going to have that A is equal to 7 and C is equal to 4. And for the B and D combination, again, we'll have negative B plus 2D is equal to 0. 4B minus 7D is equal to 1. And displaying as an augmented matrix. Okay, so we have negative 1, 2, 0 for negative 7, 1. And running this matrix through the same treatment as I had with the matrix representing the inclusion of the A and C term coefficients. So I'm taking the opposite sign of the first row. Again, I have 1 and negative 2, but now the top row concludes with 0. In the bottom row, again, I have 4, negative 7, and 1. Following through and taking the second row and deducting from it 4 times the first row elements. So we have 1 to result as I take negative 7 minus 4 times negative 2, and 1 minus 4 times 0 is 1. So the bottom row is going to be 0, 1, and 1. And then finally getting to the reduced row echelon form, I'm going to add twice the second row to the first. So the top layer or row is going to be 1, 0, 2. The bottom still at 0, 1, and 1. So here this will signify that B is equal to 2 and D is equal to 1. And then consolidating, it's going to turn out that for the inverse, okay, so we have 7, 2, 4, and 1. And again, we have with the other follow through, we have A times the identity is equal to the identity times the inverse. Again, setting it and clustering. Okay, so I have negative 1, 2, 4, negative 7 for A. I, again, have 1, 0, 0, 1. And following through, taking the opposite sign of the top row. So the transformation have 1, negative 2, negative 1, 0. And then taking the second row and deducting 4 times the top row. So I'm going to have 0, 1, 4, and 1. And then looking at converting the negative 2 in the top row to 0. Once again, I'm going to add twice the second row elements to the first row. So here I'm going to have 1, 0, 7, 2 at the top, 0, 1, 4, 1 at the bottom. And for the last two columns, the values will be in reference to the inverse. And guess what? The inverse I had at 7, 2, 4, and 1 with the first approach. And with the second approach, I come out to the very same result.